Estimating the cost of a 400 amp single-phase service upgrade requires careful consideration of both material and labor expenses. The project involves installing a new service entrance, upgrading the wiring, and ensuring compliance with electrical codes. Let's break down the key components to consider for an accurate estimate. Firstly, the service entrance itself needs upgrading to accommodate the 400 amp capacity. This includes the service panel, which should be rated for at least 400 amps and have sufficient breaker spaces for the anticipated loads. Ensure the panel is UL listed and meets all applicable safety standards. The cost of the service panel can vary depending on the brand, features, and availability, but a quality 400 amp panel will be a significant part of the material cost. Secondly, the wire size is critical for handling the 400 amp load. Based on the information provided, the plan includes running 500 MCM copper or aluminum conductors. The specific type of conductor, whether it is copper or aluminum, will significantly impact the material cost. Copper is generally more expensive than aluminum, but offers better conductivity and corrosion resistance. Aluminum conductors must be properly sized and installed to account for their higher resistance compared to copper. Check the National Electrical Code, specifically Table 310.15 B16 or its equivalent in the relevant local code, to verify the ampacity of the selected conductors for the installation conditions, including the insulation type, ambient temperature, and number of current carrying conductors in a raceway or cable. Thirdly, the installation method influences the overall cost. The description mentions an overhead service with 500 MCM wire running from a pole to the house and machine shed. This involves securing the conductors to the pole, installing appropriate insulators and hardware, and ensuring proper clearance from the ground and other objects as specified by the NEC. The cost of the hardware, such as insulators, clamps, and weatherheads, should be included in the material estimate. Fourthly, the labor involved in running the overhead service should be carefully estimated. The length of the run, the height of the pole, and the accessibility of the house and machine shed all affect the time required for the installation. Consider the need for specialized equipment, such as a bucket truck or crane, to safely and efficiently install the conductors. If the existing service pole needs to be replaced or reinforced, this will add to the labor and material costs. Also, the two 75-foot runs of 4/0 aluminum URD need to be calculated in as well. Fifthly, the grounding system needs to be adequate for the 400 amp service. This typically involves installing a grounding electrode system consisting of ground rods, crown plates, or a connection to a metallic water pipe. The size of the grounding electrode conductor should be based on the size of the service entrance conductor, as specified in the NEC Table 250.66. Ensure that all grounding connections are properly made and protected from corrosion. Sixthly, permits and inspections are essential parts of the service upgrade. Obtain the necessary permits from the local electrical inspector and schedule inspections at various stages of the project to ensure compliance with the electrical code. The cost of permits and inspection fees should be included in the overall estimate. Seventhly, consider any additional work that may be required, such as upgrading the meter base, installing surge protection, or making modifications to the existing electrical system. These additional items should be clearly identified and priced separately in the estimate. Eighthly, calculate the labor costs based on the estimated time required for the installation. Factor in the hourly rate of the electricians, including any benefits, insurance, and overhead costs. A 400 amp service upgrade is a significant project that requires skilled labor and attention to detail. Ninthly, add a reasonable profit margin to the total cost of materials and labor. The profit margin should reflect the risk involved in the project, the level of competition, and the value of the services provided. A typical profit margin for electrical work is between 10 and 20%. Tenthly, the existing service pole must be inspected for integrity, stability, and longevity. It may need to be replaced if there is any rot or other damage. To summarize, a comprehensive estimate for a 400 amp single-phase service upgrade should include the following items. Firstly, the cost of the 400 amp service panel. Secondly, the cost of the 500 mcm copper or aluminum conductors. Thirdly, the cost of the hardware for the overhead service. Fourthly, the labor cost for running the overhead service. Fifthly, the cost of the grounding system. Sixthly, the cost of permits and inspections. Seventhly, the cost of any additional work. Eighthly, a reasonable profit margin. Considering the details provided, let's analyze the reasonableness of the $3,218 bid. The information suggests that the labor hours are estimated to be around 14. This implies that the hourly rate would be approximately $230 per hour. The reasonableness of this rate depends on several factors, including the location, the complexity of the project, and the level of expertise required. In general, electrical contractors in urban areas tend to charge higher hourly rates than those in rural areas. This is due to factors such as higher overhead costs, greater competition, and a higher cost of living. The complexity of the project also affects the hourly rate. A simple service upgrade may command a lower hourly rate than a more complex project that involves troubleshooting, problem-solving, and specialized skills. The level of expertise required also plays a role in determining the hourly rate. A master electrician with years of experience will typically charge a higher hourly rate than an apprentice electrician. To determine whether the $230 per hour rate is reasonable, research the going rates for electrical contractors in the specific geographic area. Contact several local electrical contractors and ask for quotes for similar projects. Compare the quotes to the estimated rate to see if it is in line with the market. Additionally, consider the specific challenges and risks associated with the project. If the project involves working in a confined space, at heights, or in hazardous conditions, a higher hourly rate may be justified. If there is a risk of encountering unexpected problems or delays, the hourly rate may need to be adjusted accordingly. Furthermore, verify that the estimate includes all the necessary materials and labor. Ensure that the estimate covers the cost of the service panel, conductors, hardware, grounding system, permits, inspections, and any additional work. If the estimate is missing any of these items, it may be necessary to adjust the price accordingly. Moreover, the choice between copper and aluminum conductors significantly impacts the overall cost. Copper, while offering superior conductivity and corrosion resistance, is notably more expensive than aluminum. Therefore, the decision to use copper or aluminum must be carefully weighed against budgetary constraints and performance requirements. If aluminum conductors are selected, it is crucial to ensure they are properly sized and installed to account for their higher resistance compared to copper, adhering strictly to NEC guidelines. Also, the existing service pole's condition is a critical factor that could substantially influence the project scope and cost. A thorough inspection of the pole for signs of rot, structural damage, or instability is essential. Should the pole be deemed unsafe or inadequate for supporting the new service, its replacement or reinforcement must be factored into the estimate. This could involve additional labor, equipment, and material costs, potentially altering the initial bid. Finally, document all assumptions and exclusions in the estimate. Clearly state what is included in the estimate and what is not. This will help avoid misunderstandings and disputes later on. The 275-foot runs of 4/0 aluminum URD must also be properly calculated in the price. Depending on the type of insulation, whether it is direct burial or in conduit, the ampacity rating of the wire per the NEC must be factored in. Make sure to take into account the ambient temperature around the wire and if dirting needs to occur for the wire as well, which could in turn affect the ampacity of the wire too. This will affect the price as well as the labor it will take. In conclusion, the reasonableness of the $3,218 bid for a 400 amp single-phase service upgrade depends on several factors, including the location, the complexity of the project, the level of expertise required, the cost of materials, and the profit margin. By carefully considering these factors and comparing the estimate to market rates, it is possible to determine whether the bid is fair and competitive. Remember to account for all potential costs, including materials, labor, permits, inspections, and any unforeseen issues that may arise during the installation process.